This is a video lesson for Unit 1, Lesson 2, the 5-number summary and its applications for our statistics class. This lesson is about a really important set of numbers that we can learn about a data set, which is called the 5-number summary. And obviously we're going to learn about how we can use this information and what it tells us about the data. So the 5-number summary is a list that tells you the minimum, quartile 1, that's what Q1 means, median, Q3, quartile 3, and the maximum value of your data set. This has several important applications in stats, which includes box plots, which we're going to learn how to construct today, measuring spread, which is one of the key measurements of a data set. We care about center and spread, so this is our first conversation about spread. Outliers talks about what data values don't really make sense for the data set. And those are big takeaways that we can get from this 5-number summary. What a quartile is, and you're going to see this as we start to play around with our data, a quartile is like a median for each half of the data set. So instead of one median in the middle, we're going to have 3 middles that we care about. We're going to care about the middle of the first half, the middle of the whole data set, and then the middle of the second half. Okay, so how do we do the 5-number summary by hand, which we're going to learn how to do before we learn how to go and do it on the calculator? Okay, so the first thing we want to do is we want to arrange the data in order. Sometimes it would be beneficial to use a stem plot for this, and that really would be more for double-digit data sets. The least value, greatest value, and median aren't that hard, and if you understand how to find a median, it's not going to be that hard to find the quartiles. So what we're going to do first is we're going to just arrange this data in order. So I'm going to look here, I've got a 1, I like to cross these off, so in case I miss a number, I figure it out. 2, 3, there's a 4, there's another 4, there's a couple of 5s, there's a 6, there's a couple of 7s, and there's an 8. So now I have the data in a little bit easier of a way to figure this out. Okay, so the first thing I'm going to do is label the LV and the GV, because those are really easy. The least value right here, that's the LV, lowest value. Okay, and then this 8, that's the greatest value. So LV and GV, that's 2 of the numbers of the 5-number summary. Okay, next I'm going to find the middle. Okay, well the middle here, we've got, I like to do this little dot system, so I'm just dotting above these, so there's 3 on the far end, 3 on the other end, 4 on each end, 5 on each end, 6 on each end. Okay, so what that means is our middle is right here, right in between the 4 and the 5. Let's just double check and count. We have 6 numbers to the left, 6 numbers to the right. Okay, good. Okay, so all you do is you take those middle 2 numbers, 4 plus 5, and divide it by 2, and that gives us 4.5. That is your median, okay, which we can call MED, or your calculator. I'm not sure if your calculator calls it Q2 or median, but a lot of people will call this the middle, the quartile 2. Okay, so we've got our LV, our median, and our GV. Now, this middle that I drew here serves as a great way of looking at the data brand new and looking at it as 2 separate sets of data. There's their first half data and there's your second half data. Now what you want to do is you want to take that first half of the data and find the middle. Well, the middle would be 2 plus 3, it'd be right here in between these two. 2 plus 3 divided by 2, so 5 divided by 2, which is 2.5. And that is your Q1. So we have our LV, our least value, we have our Q1, 2.5, we have our median, 4.5, and then on this far right side, we've got 6 pieces of data, right in between the 6 and the 7, that's our second half median, or our Q3. So 6 plus 7 divided by 2 is 6.5. And that is our Q3. And there you go. You've got your 5-number summary. Your 5-number summary, which I'm running out of room here, your 5-number summary is going to be 1, comma 2.5, comma 4.5, comma 6.5, comma 8. And that's your 5-number summary. We'll learn what to do with that in a little bit, but that's the 5-number summary. Okay? Now, in a bigger data set, we might not want to have to go through all this work, so we might want to use our calculator. And I am going to do that with you here by pulling up my calculator and going to a really important place on our calculator, which is the Stat Edit menu. So I'm going to leave this screen. I'm going to pull up here, and we're going to go to Stat, and Edit is right there. Now, my calculator has a whole bunch of data in it. So what I'm going to do is I'm going to go up to the top, and I'm going to hit Clear, and it's going to empty that data set for me. Okay, so I want to empty that data set, and I'm going to start putting in our data, which I have pulled up off to the side here, but if you're split screen, you should be able to see the data and start typing that in. So I'm going to start putting that in. If you want to do that with me, great. If you want to pause the video and fast forward, I don't care, but we're going to have 7, 24, oops, 24, 3, 6, 8, 17, 14, 12, 11, 7, 23, 45, 6, 2, 4, 100, 6, 0, 6, 9. Okay, now I notice here, if you look at where it says 20, it just tells me there's 20 data values. If we look back at our data set here, we see that there was 1, 2, 3, 4 rows and 1, 2, 3, 4, 5 columns, meaning 20 pieces of data. So it helps to look at that and make sure that you have the right number of data. Okay, so bouncing back here, what we're going to do to go and find this 5-number summary is we're going to leave this, so second quit. We're going to go to Stat. Now we're going to go to Calc and hit Enter on one var stats. Make sure it says L1. And we get some of these funny symbols and numbers, which some of them you know what they mean, some of them you don't. But if we slide down here, we see Q1, or we see min X, Q1, median, Q3, and max. And that is actually LV, Q1, median, Q3, GV. So the calculator just did it for you, which is great. So if I come back up here, I'm just going to look at that list that I had on my calculator, and that tells me that the min was 0, the Q1 was 6, the median was 7.5, the Q3 was 15.5, and the maximum was 100. And there's your 5-number summary. Really easy from the calculator. There's times where that's worthwhile, and there's times where it'd be easier to just do what we did up here, because I could just do all that by hand really quick. The typing into the calculator takes some time. So it's up to you if you want to do it by hand or by calculator. You will definitely get the calculator available to you on the test. So now we move into box plots, which box plots are really a visual representation of your 5-number summary. It's one of our first statistical graphs that we're dealing with. Okay, a lot of people will call this a box and whisker plot, and basically all you're doing is you're just plotting the 5-number summary on a number line, and you're drawing this shape here, which I'll show you how to do in just a moment. Okay, so we're going to take that data from example 1, and we're going to make a box plot. Okay, so example 1's 5-number summary, I'm going to go and copy and paste that from over here. So that I have the data. Okay, the data was right here. Okay, so what I'm going to do is I'm going to take a number line. We want the number line relatively low here. So there's the start of it. There's the end of it. Okay, I want it to go up to 8, and I want it to be decently spaced here. So I'm just going to start at 1. Okay, 1, and then there's 2, 3, 4, 5, 6, 7, 8. And I'm just doing the best job I can to keep that as nicely plotted as I can. Okay, and then I'm going to go to the different numbers on the 5-number summary. So there's 1, there's 8, sorry, 2, 3, 4, 5, 6, 7, 8. Okay, and above each of the numbers of the 5-number summary, I'm going to draw a dot. So above 1, I'm going to draw a dot. I like to cheat on Notability. If you're on Notability, I like to cheat on it and just kind of draw this guiding line, and I'll delete that in a minute. But it keeps all the dots nicely in the same place. So 2.5 is going to be right here. 4.5 is going to be right between 4 and 5. 6.5 is going to be right between 6 and 7. And 8 is obviously right above 8. Okay, now I get rid of that line. Okay, and I've got 5 evenly spaced dots. So the reason it's called a box and whisker plot is because it has a box and it has whiskers. So right here on the ends, you're going to draw your whiskers. And in the middle, we're going to draw a box. So we're going to take 3 vertical lines through the 3 dots, and we're going to make a box through those. And that's it. That is a box and whisker plot. It's really simple. Okay, and it just shows you how evenly spaced the different quarters of the data are. The first quarter, middle 2 quarters, and then the last quarter. So if you see something with like a really long whisker or a really small box, we will learn what that says about the shape of the data. Okay, now we're going to go and take our 5-number summary from example 2. We're going to paste that. We'll shrink it down so it fits. Losing it. There we go. Let's make it real small. Okay, so there's our second set of data. Now, much bigger numbers here, so I might go by tens on this number line. And sometimes you'll have the number line provided for you, so it'll be easy. But I'm going to probably go by tens here. So 0, 10, 20, 30, 4. I'm going too big. Let's make it smaller. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Nobody said I had to be perfect. We're just, roughly sketching this as well as we can. Okay, so 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so I'm going to go over the LV, draw my point. Like I said, I like to go and draw a straight line because Notability will do that for you and just keep everything even. I'm going to go over 100. That was the maximum value. Okay, I'm going to get rid of that. Well, no, I'll keep the line for a minute. 6 and 7.5 are barely, they're in this first little quadrant. So 0 to 10, 6 is just a little bit past halfway. 7.5 is like next to that. 15.5 is about halfway between 10 and 20. And then 100 is obviously all the way over there. So I'm going to get rid of this line, and you're going to notice a pretty significant issue with the shape. Okay, there's that whisker. There's that whisker. Vertical line, vertical line, vertical line. There's our box. You notice this guy has a really long whisker. Okay, and we'll start to talk about what that means later. But you're going to see funny shapes. They're not all going to be pretty like example 3 was. Okay, so now we're going to get into this idea of spread. So measures of center, mean, median, mode, we've talked about those. Measures of spread are just as important, and we've got 4 of them that we'll talk about in this class. We've got range, IQR, standard deviation, and variance. IQR is the weird one here that you probably don't know about. Range is the really easy one that you've, I'm sure, heard of before. Okay, so range, really simple, greatest value minus least value. The other ones we're going to talk about here in a second. Okay, now standard deviation, I'm sure I'll talk more with you about this in this class, but standard deviation talks about how spread out the data is. It's a special measurement that tells you that the smaller your standard deviation, the closer the data is together. The larger your standard deviation, the more your data is spread apart. Variance is just standard deviation squared. I don't have a really good explanation for it. It's just standard deviation squared. Okay, so what we're going to do here for this problem is we are going to find all 4 measures of spread, and we're going to do exactly what we did to go find that 5-number summary. Okay, and we'll see everything that we need to see on that screen. So I'm going to go back into my calculator here in just a moment, and we are going to type in this data. So here we go. I'm going to go back into my stat edit. I'm going to clear out L1 by going to the top and hitting clear. And I'm going to start typing in that data, which I can see, and you should be able to see through your split screen. 32, 35, 2, 37, 28, 30, 42, 45, 41, 49, oops. Let's go back. Where was I? 41. So 49, 29, and 120. I had that little mess up, so I'm going to double check, but yeah, there should be 12 pieces of data, and that's what I have. Okay, now again, I'm going to go into Stat, Calc, 1var Stats. Now, there are some important things here, so what I'm going to do is I'm going to take a picture of this, get as close as I can. I'm going to slide down and take a picture of this. And we're going to use those pictures here in a moment. Okay, I'm going to pull this up using my information from the calculator. Let me dump this in for you. So I'm going to take this picture, put that up here. Feel free to fast forward the video until I've got this the way I want it. Okay, so I've got that video, or that picture. I'm going to go back up here. We're going to add this picture. Crop that. All right, so using this information, I should be able to find all the different measures of spread. So the first of the measures of spread that we talked about was range. So the range is going to be the GV minus the LV, which, according to this, the greatest value is 120 and the least value is 2. So we're going to take the greatest value, 120, minus the lowest value, which was 2, and that's going to give us a range of 118. Okay, the next thing that we're going to find is going to be the IQR, which I gave you a little formula for here. IQR is found by taking your Q3 minus your Q1. Okay, well, according to this, my Q3 is 43.5. And my Q1, according to this, is 29.5. And if I subtract those, 43.5 minus 29.5, I get an answer of 14. So my IQR is 14. We'll talk about IQR we need to just be able to state it, obviously, but there's also an application we're going to see in just a moment about how you can use this to find an outlier. Okay. The other measures of spread are standard deviation and variance. Okay. Real important here about standard deviation. On your calculator, standard deviation is given by S. That's really important. Get that on a cheat sheet because people tend to give the wrong number. It's not sigma. Sigma means something, and we'll talk about that later, and it is related to standard deviation, but S is the number we want. Okay, so this number right here, that's your standard deviation. So our answer here is 27.65. That's where we're going to round this. Finally, we're going to talk about our variance. Your variance is S squared. So we'd have to do just a little bit of work. Variance is S squared. Okay, so in this case, that's going to be 27.64986712 squared. I'm going to take the exact number from the calculator when I square it. So 27.64986712. That's just what the calculator had said. Okay, and we're going to square that, and my calculator says that that's 764.52. And now we have all four of our main measures of spread. All right, and now we're going to look into determining when something is an outlier. So an outlier is a data value that doesn't really make sense within the whole data set. It is one particular data value that doesn't really do a good job of describing what the rest of the data value does. So a lot of times in math, we can throw that number out and treat the data set as if that number didn't even exist. So what we are going to use is something called the IQR range. And that's going to be given right here. It's a special formula. Okay, and it's all things we know. Okay, we know the IQR. We can do that using Q3 minus Q1. Obviously the number 1.5, and then Q1 and Q3, those are all numbers we know about. Okay, so we're going to go back to example 5, which is the one we just did. Okay, and we are going to determine if there's any outliers for the data set. So the way we're going to do that is we are going to fill out this formula. So I'm going to write it. Our formula is Q1 minus 1.5 IQR. IQR is all one thing. Through, that's what this comma means, Q3 plus 1.5 IQR. Okay, well, we're going to look back at that last data set and see what we know we have. Well, Q3 up here in this previous data set was 43.5. We see that right here from when we found IQR. And Q1 was 29.5. We see that from up here. Okay, so we know our Q3 and our Q1, so I'm going to write those in. Our Q1 is 29.5 minus 1.5 times our IQR. Our IQR from up there was 14. Remember right here, our IQR was 14. So our IQR is 14, that goes here. And then we're going to go and put in Q3, which is 43.5, plus 1.5 times our IQR, which is the same number it just was, 14. Okay, and now we're just going to use our calculator to calculate this. Okay, so we're going to do 29.5. I'm typing this into my calculator right now. So I'm going ahead and typing that. And I get 29.5 minus 1.5 times 14 is going to be 8.5. And then we're going to go and do the same thing with plus, so 43.5 plus 1.5 times 14, and that's going to be 64.5. Now, what this range tells us, so that's our outlier range. What this tells us is all the numbers that wouldn't be considered an outlier. So anything from 8.5 through 64.5 would not be considered an outlier. Anything outside of the range would be considered an outlier. So I'm going to look at my data set here, okay? And if I look at my data set from example 5, I see two numbers. I already highlighted them for you. I see two numbers here, 2 and 120, that are outside of the range. All the other numbers are between 8.5 and 64.5, okay? But not 2 and 120. So 2 and 120 are outliers because they are outside of that range of normal values. And that's how we do our outlier determination. We use this formula here. We plug in what we know. We get a range, like what I highlighted down here, and we see whether or not there's any numbers that don't fall within that range. Okay? The last thing we're going to do here is make a really rough box plot for this data set that was given, which, nice enough, it's already in numerical order. And we are going to answer a couple of critical thinking questions about it. Okay, so the first thing we're going to do is construct the box plot. Well, to do that, we need our 5-number summary. For this data set, I see, I'm going to try to find the middle here. Okay, so 1 on each end, 2 on each end, 3 on each end, 4 on each end, 5 on each end. That means that the 11th number here in the middle is our median. Okay, now the median separates the data into two halves. Here's the first half, here's the second half. Now we're going to find the median of each half. So the middle number here is 65. We're going to call that Q1. The middle number over here is 73. We're going to call that Q3. Okay, and then obviously the first number in the data set, the LV, is 54, and the last number, 76, is the GV. And that's our 5-number summary. So we don't need a lot of space. I'm going to come over here, and I think I'm going to go from 50 to 80. I could go by tens here. Okay, so I'm going to draw a number line. We'll do this in a different color. Okay, I'm going to draw a number line. We're going to go from 50, 60, 70, and 80. Okay, we're doing a really small box plot here, and that's fine. Okay, our LV is 54, so about halfway here. Okay, our LV is going to be 54, about halfway between 50 and 60. Okay, our Q1 is going to be 65, so halfway between 60 and 70. Okay, remember I can do this little notability trick where I take the straight line, make it a little bit easier. 65 right here. Okay, 69, a little close to 70 here for the median. 73, just a little bit past 70 over here. Okay, and then 76 over here, so not a lot of separation. Okay, I'm going to get rid of that line now. Okay, here's a whisker, vertical line, vertical line, vertical line. This is the middle box, and we've got our box and whisker plot constructed. Okay, finally they ask us to do a couple of critical thinking questions. The first one asks us, what would happen if we changed the max to 85? So we're changing it. We're not adding a number, but we're going to change the 76 to an 85. And how would that affect the mean and standard deviation? Well, the mean is found by adding up all the numbers and dividing by how many there are. So the mean is definitely going to change if you change one of the numbers. Standard deviation is found in a very similar way. So both of these, by making one of the numbers bigger, both of these numbers are going to change, and they're both going to go up. Okay, so mean and standard deviation would both increase. They're both averages. Both the mean and standard deviation are averages, which means you're adding things up and dividing in a certain way, and that means that they would both change if you changed one of the numbers. Okay? You might think, well, yeah, obviously, if you change one of the numbers, everything would always change. Well, not everything. Okay? So the second question says, what if we change the min to 45? So this 54 min, we're going to change it to 45. How would that affect the median and the IQR? Well, think about the median. The median's the middle number. If I take one of these numbers and change it to a different number, isn't, as long as, I didn't, change to a number that magically moves it to the beginning or to the middle, it's still going to be the minimum. It's still called the minimum, so it must be something smaller here, 45. Okay. Would the middle number change? No, it's just a different first number, but the middle number is still going to be 69. So the median would not change. Okay. Median would not change. Notice I left a little gap there because we're going to notice the same thing about IQR. The IQR is Q3, which changing 54 to 45 is not going to change Q1 or Q3, which are what's used to find the IQR. So the median and the IQR would not change from changing what the minimum, or in this case even the maximum, would be. And that's all for this lesson. You'll get more similar questions throughout the homework that will kind of force you to think about, if I changed one of the numbers, how would the statistical measure